Hello. So hello everyone. Let me share the link to the notes. So we're going to do the agenda building part of the meeting. Oh yeah, Micah shared the notes already in the chat. So you'll find the link to the Google Doc with the sync notes. I created an item for October 29th meeting. So you can put your name, where you work with, if you feel comfortable if you feel comfortable sharing, and what you want to talk about today, and we are going to build the agenda for that from that. So feel free to also add to the agenda section about what we're doing.
Congratulations on joining Databricks, Julian.
So I was typing my name, and then I was reading Micah's item at the same time. So I started typing data, and it's just like, what am I typing? I did not. I know a lot of people did join Databricks. I did not. So far, like, who knows?
I think we're eventually going to hit a singularity of so many companies with data in the name. We're just going to start getting confused.
Well, I just did, right? It's just like, I was like, what am I typing? I'm not. So yeah, on my end, I'd like to talk about the new. Yes, thank you, Arnav. I was going to add it as well. The new encoding, and also the footer. I don't know if Alkis is in the room today. Right, so don't hesitate, right? This is the magic of collaborative editing of documents. Don't hesitate to add more stuff in there. Yeah, and if you don't have the edit access right now, just use the suggestion mode, right? You know, you can go to view mode and suggesting, and then, you know, someone with edit access will approve your change, right? So don't feel limited by not if you haven't joined the group yet. And let's see. Yeah, we have 10 people in the call. 2, 3, 4, 5, 6, 7, 8, 9. So most people have filled in. So nobody, I think, they want to talk about. It's just me. Okay, we're ready. Okay, let's get started. So on the new encoding, I think last week, 2 weeks ago, we talked about ALP. I don't know if there's any update yet on that, or if it's still.
Yeah, based, some of the people, commented on the doc saying that we'd like numbers for data sets that someone had done for byte stream split. So we've been doing that. And I think even with those numbers, ALP tends to do better. I just got those numbers today, so I haven't updated that original doc. I can, if possible, share the screen.
Oh, yeah, I can release this share. Here you go.
Let's see. Do you guys say something by the name of external latest float compression benchmark?
Yeah.
Okay. So these were the data sets, and I'm just looking at the compression ratio right now. These were the data sets I think that were pointed out in that paper, which we extended the evaluation for, and I should do something like this. So for the byte stream, comparing it with byte stream split, in except like these three cases where byte stream split tends to do a little better, and in some cases a lot better. The ALP algorithm with either the decimal encoding, pseudo-decimal encoding, or the LPRD compression tends to do better. So, and decompression speed, in almost all cases, ALP is going to be much better than the byte stream split. So in a bunch of these cases, it's like 4 to 5 times better. So one thing that I wanted to ask the team is what is, like, do you guys want, like, ALP has two encodings backing it, the decimal encoding, pseudo-decimal encoding, and the real double encoding, which is a little dictionary based, and then byte packing. Are people, based on how other engines look at various compression schemes and evaluate what route to take, like, engines will have their own sampling logic and decide what thing to do. Should ALP continue to have, like, backing it one of the ALPRD and the pseudo-decimal thing, or should it by default, based on sampling, decide on byte stream split also? So one of the suggestions from Antoine was we should, in the first implementation, have the pseudo-decimal, and if that doesn't do well, fall back to byte stream split.
I understood that as like separate from ALP itself. I think that was an implementation detail where you say you try encoding with ALP. If that doesn't work, you would fall back to byte stream split separately as like a writing thing, and then try to compress the page. I don't think it was part of like modifying the ALP algorithm, or at least that's not how I understood it. If that
Okay.
if that makes sense.
Maybe I understood wrong. I thought what he was suggesting was we should not do ALPRD is a little tricky implementation, and instead of falling to ALPRD, wherein it it doesn't have, even in the cases where it tends to do better, based on my understanding, I think you tend to take the LPRD route for let's say POI. it's not, doesn't have a significant advantage in terms of compression ratio. And I think one more, if I remember correctly, the message Lou and the numbering in these cases, it tends to take the LPRD route. It doesn't do significantly better than byte stream split in terms of compression ratio, but it tends to do better in terms of decompression speed.
Yeah, so I don't see a reason, given that I don't necessarily see a reason to like fall back to byte stream split, right? Because byte stream split.
Okay.
Yeah, like it doesn't seem like we need to do that. I mean, we should discuss on the mailing list and clarify exactly what Anton was thinking. Anton was thinking, but like I don't at least in my mind, given these numbers, I'm fine just adding ALP, and I think there's a known gap, I think, in like all of the writer implementations today where we just aren't smart about picking encodings. It's kind of a very like, not that there's a lot of options, like if you don't want to touch V2 encodings, but we just say like pick this encoding first. If this encoding gets too big, like start encoding pages with another encoding. And so like logic there can potentially be improved, but
I think, yeah.
But if you're getting similar compression ratios and you're still faster decoding, it doesn't seem like falling back to byte stream split is worth it.
Okay.
At least in my mind, right? Like, sorry, go ahead, Julian, I cut you off.
Well, sorry, you were not done. So I just, I was thinking this is a separate concern as well, because there's adding the encodings, right? And there's going to be the strategy we use in the open source implementation, right? Whether it's the Parquet Java or the Arrow Rust Parquet implementation and things like that. And then it's a bit of each engine can determine what's the right strategy for them to pick an encoding as well. And I think it's fine, and it can be independent. I think Parquet can have a recommendation on how to do it, but at the same time, it's the kind of things that it's really, people should have the freedom to decide what encoding they pick when they write Parquet files in their own engine, right? Given some reasonable, constraints of,
yeah.
And so it's less important at this stage, right? We could even say, hey, if someone wants to decide to always fall back to byte stream split, for that special case where it's slightly better in compression, well, they can do it, right? It's their choice, as long as everybody knows how to decode the thing.
Okay. So like what you're suggesting is like all the decision logic of what to do should not be behind a single encoding scheme. That decision should be in the engine, deciding based on its trade-offs.
And we can decouple those two discussions, I would think, right? You can have one discussion how we implement ALP, how we make it available, and we can have a separate discussion how we pick the best encoding.
Okay.
Because there's always also a trade-off of how much time and memory we use for trying things too, right? So it depends a little bit of your context, what you're willing to give to that.
Yeah, I would propose a test if you have to change the spec at all. That's a different conversation than don't change the spec, but we could change the implementations to get some better trade-off. And I actually posted in the chat too, there's a conversation that came up in Rust, right? Where like some of the more advanced academic file formats propose like basically trying a bunch of different encoding schemes and then picking which one works best or whatever, sort of dynamically. And again, that doesn't require changes to the spec at all. That's like an implementation detail.
Okay.
Yeah.
So then in that case, like deciding between ALP pseudodecimal and the ALP real double schemes, should that also be offloaded to the engine, or should that be done by a given encoding? So right now ALP does the deciding, but would it be better for the engine to do it and we just have two implementations of a float compression scheme, encoding scheme?
Would you have to change the decompressor?
The decompressor again would decide which, two enums, ALP pseudodecimal, ALP real double, and create the right decoder.
Can this change within a page, or like I guess that's the that's kind of the question. Is it like one ALP encoding that can then like change and reset? Does it reset like every 10, 24 values, or does it stay consistent?
I think the frame for the pseudo-decimal ends up is 1024 values, but the encoding scheme stays the same for the entire page or row group, whatever block high format considers.
Yeah.
That simplifies a lot of this ALP sampler and a bunch of that logic, and might be an easier change to make.
So if I understand correctly, you're just saying we have two encoding scheme. We break ALP up into two encoding schemes. One is ALP pseudo decimal, and one is ALPRD, and that's per page. And then yeah, like I mean, if it's not adding any value, I think it's worth discussing and just like recommending one on the mailing list. It seems like if it's not adding any value to like have ALP be an abstraction and like it's something writers could choose, then it probably pays to split them out. And like this kind of gets back to one of the things we also want to do is like hierarchical encodings, right? And so like
yes, exactly.
If you're doing that anyways, then it's like having finer grained things probably doesn't make a huge difference.
Yes, exactly. That's the point I was trying to put forward. One final, I'll put that on that thread itself, looking for suggestions. One final thing, I think Julian brought it up that, right now when we go to ALP decimal encoding, we always go with Bitpacker, and in future, we want to have the flexibility of using fast lanes or other packing schemes. So to the original suggestion from the paper, we'll try to add another point where we can decide which thing to future-proof it.
Yeah, that seems just, yeah, for that, hopefully we aren't adding another, hopefully we aren't multiplying the number of encoding.
No. It'll be a part of the metadata for the ALP pseudodecimal itself.
Yeah, that seems like a good idea. I don't know if you want to it seems like a much potentially bigger project to take up design for general hierarchical stuff, but like within ALP, we can probably just do something and then come back to something that's more general.
Yes. Cool. That's it for me. Andrew, you might be on mute. I can't hear you.
Sorry. So the idea is you'd parameterize ALP by the encoding scheme you would like to apply for the underlying transformed values. Is that the idea?
Yes. Like reserve a byte to tell what to do. Yeah. Thanks. Yeah.
I think we can also maybe some of this can be informed once we get to implementation. If something is particularly more awkward about having two of these things than one of them, hopefully that plays out when we go and look at implementing it.
Okay. Yeah.
Okay.
So what are the next steps?
We, all this evaluation has been on the internal code repo. We are right now working towards porting it over to the Arrow thing. So I think I need to send out emails looking for consensus on, two separate encodings, or, just ALP doing all the thing. And once I get a consensus, I think just having an implementation over there. I think one of the questions that Andrew did ask, I think on the doc was, what does the implementation look like? Is it similar to the one that the paper presented? I looked at the code again. I think at that point it was read the paper, try to have an implementation. The building blocks and the core kernels are very identical. So at this point, I'm just going through both the implementations and seeing which one would fit the best, and we'll port over that.
Yeah, and I think probably the main blocker for a second implementation is probably the proposed spec change, where we describe what the encoding is, and that way somebody can go. We can make sure if the job implementation manifests itself, we can make sure it's according to the spec rather than feeding off the like C++ implementation, just to make sure that it's clear what we are proposing. Like we have a clear thing that people can work off of, and ideally we also test for compatibility with some of the other like Rust libraries, just to make sure there aren't subtle differences. But
Oh, yeah, well, I mean, once you guys have an implementation, I fully intend to try to convince someone or ones in the Rust implementation to do a compatible implementation by ranking what's in Vortex, basically. But yeah. So
Yeah.
Stay tuned.
yeah, I did think it was just part of it. Yeah, but like, yeah. So that sounds great. It seems like great progress.
Thanks.
FSST. Is that
So I had one last question before we move to the next thing. So I think Andrew, the discussion you pointed out in the chat, like about how to pick a better encodings that is happening in the Rust implementation. It'd be nice to have this also at a higher level, right? Like it's kind of to see if like the Java implementation should also implement a similar thing. I don't know, if we have something that works well in one of the implementations, it should probably cross-pollinate to other places as well, at least for the open source implementations of Parquet.
Sure. So maybe I'll start a mailing list discussion and point people there, and we can coordinate from there.
Yeah, I mean, like if I haven't read through it, but again, this seems like implementation details. I think, Andrew,
Absolutely.
You've been very good about following up, saying like, "Hey, we tried this thing, we saw really good results," and just like posting it to the mailing list. So
Yeah.
that just gives impetus for somebody to go look at the other.
Yeah, and I don't mean to oversell what's going on there. I'm just saying what came up with someone's like, hey, it would be nice if we did some dynamic sampling approach. You actually look at what the data is, figure out what the encodings would work best given that actual data distribution, and then do that. And you don't actually even need to do that in the encoder itself. You could do it else outside, but yeah, I'll send a note. Yeah.
Cool. Nice. So yeah, FSST. So Arnav, you've been trying it out. Do you want to share your findings?
Yeah, let me share my screen. Thanks, Julian. I think this will work. Is my screen visible?
Yes.
Okay. Yeah, thanks, Andrew and Micah, for the review. So I'll quickly go through, like maybe take 5-10 minutes going through the doc, and if there's any suggestions, feedback, would love to hear what you guys think. So yeah, so I tried to implement FSST in the Arrow implementation for now. And right, FSST is used like all across in different engines, DuckDB, MongoDB, Vortex, a couple of others. And this uses the open source implementation of FSST that the authors have published on GitHub. And we added a patch, a custom decoder, FSST decoder with an arrow that and an encoder that encodes and decodes strings using that implementation. So yeah, the first sort of point is that FSST is implemented as an encoding scheme, like not a compression algorithm. So it can be something that is built on top of dictionary encoding as well, need not be something very isolated. But for the purpose of this benchmark, the results are purely FSST and dictionary encoding side by side. In reality, we can have one on top of the other. So yeah, according to the paper, the results are very good. Like the paper claims 1.5 to 3 times improvement compared to plain or dictionary encoding, 2 to 4 times faster encode or decode compared to ZSTD, and yeah, fully streaming decode. So these numbers hold true for our benchmarks as well. Before going to the benchmark, I'll quickly go through the high level. So the implementation is straightforward. It's just 2 files of C++ code that's there. It's available both in SIMD and non-SIMD as well. So the idea is that we just build a symbol table. We do a couple of iterations. The goal is to find the substrings with the maximum amount of gain, non-repeating, non-overlapping substrings that appear frequently within the data set. So yeah, using that, we'll have to make a spec change in Parquet thrift just to add support for the new encoding, but there's no thrift changes as such. In terms of the evaluation, there's no security risks right now. There's no dynamically loaded bytecode. Bad metadata usually fails, or we won't have an inconsistent state. The decoding side will have access to the symbol table and will be deterministically be able to encode and decode. Yeah, I wanted to discuss the third-party dependency. So right now there are multiple open source implementations of FSST. I think there's one famous one for C++. There's one more for Rust. These seem to be, at least the C++ implementation seems to be well maintained outside as well. The authors seem to be getting patches regularly. So one option is we could use that, or the code is straightforward. If you guys think we want to have it as our own implementation, that's also feasible. For this benchmark, I use the open source implementation because they seem to have it's well written, at least the SIMD side of things. But we can add our own implementation as well. Yeah, in general, it's GPU friendly, point access friendly. It's the same type, so bytecode in byte stream in, byte stream out. We don't change anything, so it's friendly towards predicate pushdowns. If you're doing equality or things like that, the compressed string equality is the same as uncompressed string equality. In terms of performance, the benchmark did two tests. The first was synthetically generated dataset of different types. This is financial IDs, IP addresses, more textual data, things like server logs, transaction IDs. So normal datasets were not giving like as much variety, so wanted to test out on our own dataset. The second benchmark is on one of the open like Kaggle datasets, which is the Spotify dataset. And we compare the compression ratio and the read-write speed across all of these categories. So in terms of the first category, like if we compare things like UUID, unstructured, highly random text, which is usually not repeating, that's where FSST gives a lot of advantage according to the paper. So we see similar results. So in cases like financial IDs, IP addresses, transaction IDs, these are like completely scrambled strings, very similar to UUIDs. We see FSST, let me just zoom in. Yeah, so FSST is like four times improvement. Dictionary encoding is 2.95. The benchmark is comparing FSST and dictionary. And these benchmarks are isolated. So it's not that we have FSST on top of dictionary encoding. Right now it's isolated. But when we actually implement it, it can be on top of dictionary and the benefit will compound. So overall, if and just to summarize it, the best case performance is around, I have that number. Yeah, best case performance is around 206%, which is also in line with what the paper presents. But there is a degradation of write speed. So there is a 5-ish% of write. I think there's a question. Yeah, that's a great point, Andrew. I can quickly wrap it up in the next 2 minutes and we could discuss
Yeah,
that.
we can get to that question after you finish presenting your doc. Yeah.
Okay. Yeah, almost wrapping up. So in terms of compression ratio, we do see good improvements. The best case improvement is 2 times. The paper also presents 1.5 to 3 times. It's variable on different types of data. The best improvement is on scrambled, non-repeating data like UUIDs. And there is overhead on the right now. But this implementation, like my CPU didn't support SIMD, so like the open source implementation, it automatically detects what can be used. So this did not use SIMD, but the SIMD implementation is supposedly more faster. I'm planning to try that out on a different hardware. And yeah, let me just go down. Yeah, but there's a couple of things that we can do on the right side, at least on the algorithm side of things. There are things, the number of iterations that the paper presents. So they claim that the symbol table can be generated within 5 iterations. That's what we also use, but practically this is like hovers around 3 to 4. Also in SIMD, the number of turns that we use, so right now that number is hard-coded to 3, and the number of iterations is 5. So that means we have 3 AVX512 registers which are feeding data parallelly to the SIMD execution units, and the symbol table is being constructed. But the authors also claim that this can be varied depending on the data characteristics. We can tune the number ourselves. And we can improve the write overhead. So yeah, this is the TLDR. This is the result also on the Spotify dataset. So we see similar results. Yeah, FSST across the board is almost at par with dictionary encoding, 2.9 times compression ratio versus 3.11. And it sometimes also is slower than dictionary encoding for repeating data. That's what I saw, repeating strings. So there we may have benefits on either standalone dictionary or dictionary plus FSST. Yeah, there's a lot more details in the doc, the numbers and all, if anyone wants to go through. We have some benefits as well. It's push down friendly. It's parallel as well. The encode can be done in parallel. Decode can be done in parallel. There's no shared state as such. And the SIMD version, they have also removed the for loops, if conditions, branching to ensure that it's more SIMD friendly. Yeah, so this is the overall results. Would love to know what you guys think.
I don't know, a few clarifications. So on the data set that you tried it on, how many rows, how many values was the comparison on? And when you zoom into, I think, let's say, financial IDs, one of the figure 1, what does the one on the x-axis mean? Like, are you doing FSST and then doing an LZ4 compression on top of it?
Yeah, I can go deeper. So on the number of rows, I think this was 500,000, but I tried with different number of rows, 10,000 all the way to 1,000,000. I can share more results. I have a whole spreadsheet. I'll share it after the meeting. The x-axis here is LZ4 and gzip working on dictionary encoding and FSST encoding. So these are different iterations. This is iteration 1 of LZ4. Blue bar is dictionary encoding plus LZ4. Red bar is FSST plus LZ4. And similarly for gzip, and we have different iterations of the same across the x-axis.
Yeah, it would be interesting. You don't have a column for just dictionary and FSST without additional compression. I think that would be interesting to compare as well.
I see. That's a good point.
Like, compression might not add much on top of those, right? So it might be useful to check that.
I could be wrong, but for text data, almost always, like unless it's very low cardinality columns, compression does add some value.
But it would be useful to be able to compare. Right?
Yeah, definitely. I'll add that. Yeah.
And is the cardinality like very low compared to the total number of values, like total number of distinct values in here, or is it because it only finds out FSST, as far as I remember, it only finds out 255 distinct substrings of length 8. So
Yeah.
in here, do you see that pattern, like anything specific in these data sets, the things that you pointed out, UIDs and financial IDs, which tends to benefit it?
Yeah, so the cardinality was intentionally very high. When FSST is unable to find common substrings, it just uses like smaller substrings of length 2, length 3. So if you imagine like we have a like XYZ, ABC, something like that. So if only XY is a commonly repeating substring, it'll only create a symbol table on top of that. But right now, the cardinality, I try to keep it high, both across financial and transaction ID. I can check the length of the symbols, strings in the symbol table as well. I couldn't take a look at that, but I can get back on the length.
Yeah, so I think it would be good to maybe compare on some more real world data sets. Like I think, the work that Pratik did with ALP just showing kind of real world trade-offs would be helpful. Instead of the synthetic things, it looks promising, and then reiterate, kind of be like very careful about like what we are comparing across the different dimensions. With the things, like I think there's a lot of data packed in here, which at least for me is a little bit hard to parse, and like having consistent patterns like from multiple data sets would probably be a little bit easier. I think the other thing that is maybe worth thinking about is if we want to correct anything else with FSST, right? Like so that we actually have skippable like string data or things like that, right? Like and how we encode the lengths of strings, right? Because that's still an open question. We might be able to do better here if we read like how we're encoding lengths.
Yeah, that's a good point. Actually. Yeah, sorry, go ahead.
I was just going to say, there's also, it seems like once people started using this in other formats, they immediately extended the symbol space. So it's not just 8-byte symbols. There's like some variant that has 12-byte symbols, or 12-bit symbols rather. So we should probably learn from that as well.
Yeah, is that what Vortex uses by default?
I have to look at what Vortex uses, but it's definitely what the next next project from Assassins people did. Like
So
the Fastens file format uses that.
What would be special about 12 bits and not like just going to, is that specific to the data?
I think one of the things you get with 12 bits is you don't need to have an escape mechanism. Like if you only have an 8-bit code, in order to encode all possible 8-bit sequences of 8 bytes, you have to have some like escape. The original paper has like an escaping clause, and so like one of the bytes is reserved as an escape character, so you can stick arbitrary stuff in there. And so I think with 12 bits you can avoid that.
Interesting.
And I think just like the 12 bits, I think is also picked on kind of cache friendliness of the dictionary, like so it doesn't grow too large.
Yeah.
But this is also really cool. It's exciting. I think design space is a little bit like bigger here for like reconsidering some of the string encodings that we should figure out if we want to call some of the stuff out of scope and just do FST by itself. But it seems like we can maybe get some easy wins cheaply if we're like considering a new string encoding here as well that addresses some of the weaknesses of others.
Adding to what Micah suggested, that trying it out on some real world data sets, like just some data point which we thought, and we didn't dig deeper a lot into it. Like for example, one of these tables that you try for that was I think sent out by ClickHouse, the hits2 table, I think. Over there we tried it out on a few columns, and it was whatever we tried, like it wasn't able to beat Z standard in terms of compression ratio on almost all of the string columns. I think URL, I don't remember URL column, but looking forward to seeing some numbers on real world data.
Michael, just to confirm, is there some data set you would recommend to use here? Like I can specifically test out on that.
Not off the top of my head. I mean, I think a good place to start is maybe Pratik, you can provide like a link to the H2 one, and also just pick some of the data sets that were listed in the doc, and it doesn't need to be exhaustive, but like pick a few that seem reasonable, just so like we start getting a basis for comparison on like open data rather than synthetic.
Makes sense. I'll try out the other data sets as well. And on the right side, I think there's a lot optimization that can be done. Right now, the string construction was we get to decide that. So I just put the number of characters of the string and the substring followed by it. So it was like number of characters substring, number of characters substring. But I think if we can group it by the same length substrings together, we can probably chunk the string better and then feed same length substrings to SIMD. I think that should be faster. So I'll try out some more encoding things, but I think the 5% overhead is the only sort of drawback that I see. And there's a couple of ways that I can think that should mitigate it. So I'll try that out as well. Yeah.
Cool.
Okay, so in the next step, I put down, so there's some establishing what open data set to test with. What else did you want to add?
I'll test out Julian on encoding as well, like better ways to encode it to avoid the 5% write overhead. I'll try it out on some SIMD hardware as well.
Okay. And we wanted to, in the table, probably see what's the difference if we don't have a compression on top of it, right? Like, so to
Yes,
see
yes.
the difference. Yeah.
I actually have that data offline.
Oh,
I'll share
yeah.
it.
You can just add it there. Yeah. Okay. Okay. Any other question on that? Because so I'm acknowledging the discussion that's happening in the chat, right? I think we can just so if we're done with reviewing RNAV the document, we can go to the embedding encodings, pluggable encodings discussion if we want.
Yeah, I think this has come up in the past. Like I think there's a few things that like we're rehashing from like document discussions on like what should be where. Like one of the reasons why we are like trying to get a few open data sets is like so we have a consistent bar for like when we add things, and like they should show significant improvements to like avoid a plethora of encodings. I think separately, I think it would be useful to have pluggable encodings in some sense for experimentation and for people that really want it, but I don't think it should be considered standard, right? Like one of the big values of Parquet is you don't need it, as I think it was Kenny said, you don't need an entire VM to like decode it if you want to. And like people know that if you use like things that are in spec, it should just work, you know, modulo like where implementations get to, which is why like we want 2 implementations of any like new feature in the spec just to make sure that it starts kind of getting out there in the ecosystem. Yeah, so my take is the WASM stuff is interesting for exploring. Like I think just a general plugin thing that allows people to say, here's a different encoding, like do your best, and say like those aren't supported by the Parquet community, right? So somebody could then use that to do a WASM plugin if they really wanted to, but not be part of spec is my take on it. Like I think plugins are useful, right? Like everybody wants, like not everybody, but there's a lot of people that like want to add like random encodings, and if they really want to do it and still like have general Parquet data, it'd be good to have that as an option rather than like forcing them to go recreate their own file system, own file format, but like not have that be like again, like that kind of breaks compatibility pretty quickly if like you just have custom things or we are too quick with new encodings that don't necessarily add value. I don't know if anybody else has thoughts there, or like if that answered, if you have more thoughts there, Andrew. I think other Andrew also. Yeah.
When I used the term plugin, I used it really generally. I was not meaning any kind of implementation plugin, if you will, but just some way that people could more easily add encodings. And it sounds like you have a general objection to this, and that's fine. It just seems like you get into a certain set of discussion. You know, is Parquet a file format, or is it a file format for certain types of data? And you know, what kind of data, you know, is being supported? There are all kinds of domain-specific data that might be encoded in some particular way. where are things going here? I don't know.
Yeah, and I'll just respond real quickly. And like, I think it is more nuanced, right? Like, I think again, we want very strong core compatibility set of guarantees for any new encoding and say this is part of Parquet. I also think it's useful to like think about an extension mechanism that do allow people with more niche data to like extend it to their whims and just realize that you lose some of the benefits of like Parquet as the de facto standard for data interchange. But, yeah.
Okay. Yeah, just being involved in the WASM side and all of that. I think one of our big, what we'll say is one of our big successes is the fact that, hey, we've, if nothing else, helped get this ball rolling on, let's add more encodings to Parquet, let's update what's going on. And so Parquet improving to us is a huge win for our considerations. So we're really happy to see like FFST and ALP getting added. I think there is room for discussion on, not sure how it would work out, but there could be a sort of almost a split side of the encodings of like, hey, look, signal that you're going to use an encoding here that you're going to be able to use whatever it is. We'll maybe reserve some kind of space for it in the, however it'll get handled, but we'll just say, you enter this domain, you're now in Wild West. We can't differentiate what you've got from a binary blob. We're not even going to try, but maybe you can do something cool with it, and that can be used for some level of additional adaptation. If not, sort of pushing it above the beyond, well, that has a lot of overlap with logical types too, as I'm talking about it. So this is definitely something that's worth considering, at least drafting up as a larger proposal of people have their own data that has very, as like you said, niche uses. And it's like, we want to at least be able to try to open a bit of a door for them. And from my perspective, that also makes it much easier to do research prototypes as well, because it's effectively a playground that's getting paved. So maybe there's something there, but I think it's worth being very careful there, because again, as Micah said, it's good to be able to guarantee that if you have a Parquet file and a Parquet reader, you can read your Parquet file and you don't have to worry about anything else. And I think that's something that needs to kind of just stay true.
Is there, do Parquet readers and writers have, is there validation for them? Is there a validation suite that people have to pass in order to check the box and so on?
There is not a current CI suite. There's a bunch of test data that we have living in the repo, which is written under various considerations, but we don't have a test harness that says read this back to be this thing. I think maybe something was introduced to support variant a little bit, but I think it's more just we have well-documented data sets. And
there was a discussion about adding a harness. Let me see if I can dig it up. We've definitely talked about it, but we don't have it. I agree.
Yeah, like a harness would be great, and it's something somebody needs to volunteer the time to do. Like the best we do is kind of ad hoc testing between the two implementations when we add a new feature, and adding stuff to the Parquet test repo, like that is canonical for those features. If anybody wants inspiration, Arrow, I think, has done a really good job of test harness here. Or at least a very reasonable job that has caught a lot of issues in the past. And any other thoughts? Or
So in general, I just wanted to know, looking at FSST, it seems this may be a new use case, but FSST seems to be an encoding that can be placed on top of other encodings. So in the future, given that we'll have other newer encodings in Parquet, uh, like what do we think about encodings in general? Do we plan to have like one encoding at a time, or do we plan to allow multiple encodings on top of each other? At least the code in Arrow didn't seem as friendly, where we can have encoding stacked on top of each other. We just have a decoder and we implement that.
Yeah.
So is that something? Yeah.
I think we want to explore hierarchical encodings, or like I call them hierarchical encodings, and if that's a standard term for it. But I think it's again something we want to justify. There, right? Like, I think we are taking a little bit of lead from the academic literature, because some of these things have gotten headlines, but again, we want to validate them on real world stuff ourselves.
Makes sense. Yeah.
Is it FSST on top of other encodings, or is it kind of below other encodings?
It depends on how we classify it, top
Yeah.
or below. But essentially, if you have a dictionary represented, whatever is in the dictionary, when you're decoding, you just take it out and look it up on the symbol table. So I would say under, maybe.
I mean, you could certainly apply other encode, like you apply the FST transformation, the lookup table, right? And then you can apply other encodings to that encoded symbol stream, like bit packing, for example. Yeah.
Yeah. Okay, and I had one last topic, but so we had this discussion, but Alkis is not here, I think. There was this thing about the discussion on the new flat buffer footer, that if you restrict Parquet files to 2 gigs, right, you can use 32 bits integer to store things instead of 64 bits, and it makes the footer smaller. But then there was a whole discussion, is it a problem to limit files to a certain size? And I just wanted to check if the suggestion I put on the list of, like, let's say we pad row groups by, like, as an example, 16 bytes, and just divide the metadata by 16, and now the limit is 32 gigs instead of 2 gigs. Is it a reasonable idea, or like, what do you think? Because that would have the benefit, right? If we add that in the metadata, we say, and look at all row groups offset and multiply them by this power of 2. And is that reasonable? And that, because that would park this discussion, and then we could move on this.
Yeah, I liked it. I think a little bit more just to give us flexibility. I think Rock, maybe you are most aware of the use case and like what the maximum size file you guys have at least seen.
I mean, as big as you can make it, but it's we like that,
Okay, yeah, I know that on our end, I see files that are not that much bigger than 2 gigs, but that reach that size. And I think 2 gigs is just a little too close to the actual size that people have actually sometimes.
Yeah, like I feel more comfortable with a little bit higher, like 64 bytes or something like that. Or
sure, yeah, I was using it as an example. I mean, we could put it in the footer, because maybe, like I was thinking, 10 years from now we'll have gigantic files. Who knows? Because we'll keep having more memories on machines and stuff, right? 30 gigs files, nice.
Yeah,
I mean, stuffing giant JSON in a column, right? You can imagine it getting pretty exciting.
Very likely. It was a white table, but there wasn't any performance reason apart from simplifying the metadata size. Restricting the metadata size to have large files.
The other aspect is when you work on top of blob storage, you pay per request, right? Like, some people tend to make bigger files and bigger row groups, so that they can reduce the number of requests they do to get, if I make a request to get a column, I get more data in one request, right? And I reduce my cost of using blob storage.
Yeah.
So that's the other thinking for making bigger files, because you pay less if you make a lot of those. Okay, well, yeah, so that's cool. That'd be my contribution of the year, is the section. Actually, it's funny. I was chatting with Pratik at the meetup, and that came up in the discussion. It's just like, oh, maybe we could just do that, and it's not a problem anymore. Okay, so I think we have 5 more minutes. So is there anything that someone wanted to mention?
I've been behind, but I'm still going to make a proposal to deprecate the file path in parquet.thrift and discuss down the mailing list.
Okay. And yeah, and I am right? We have an optional column headers, right, on the column chunk in the file, right? The way this works is sometimes we have the column, I forgot the straight structure that define the column metadata at the beginning of the column chunk, and sometimes we don't, right? Because the spec says it's here, but the Java implementation never put it there. So it's become optional. Is that correct?
I remember there being some oddities there, but I don't remember the details.
So the way, so I've been writing. So last week I've made a little Parquet visualizers that visualizes the metadata, and so I've been playing with various files, and that shows the size of the pages and what encodings it's using, and it's kind of for people who are trying to optimize their Parquet files. And so it looks like so in the footer you have the index of the column chunks, right? And then you have the pages, and in the metadata you have the index of the first data page, the first dictionary page, and powered by Parquet. Yes, Parquet is nice. So you have the index of the column chunk and the index of the first page, and the first page is not necessarily at the beginning of the column chunks, and sometimes there's the column metadata itself is put there again, I think. Anyway, just a thing that a little leftover from underdefined spec at the beginning, and that's I think we had reasonably few of those little quirks that happen from underdefining the spec earlier.
Whatever we decide on the column metadata part, if you have a tool, please share.
Oh yeah.
Visualizations, it'll be helpful.
Yeah, it's just I built a thing so that it visualizes not the data but the metadata, right?
Yeah.
Kind of because if you look at the footer, you don't know how many pages you have. Okay, this the one that was just shared, actually pretty similar. Kind of interesting. Okay. And looking at, because like people write Parquet files and they say, hey, it's bigger, right? It's bigger because you have way too many small pages, or it's using the wrong encoding, or you're trying to use dictionary and it falls back to plain right away or something. And things like that. So, and it's not obvious to know what it's using when you look at the file. Yeah. See you. Thank you all for being there. Bye-bye.